Good day, viewers. This is JJ Peters from Central University of Technology. I am a BEng electrical engineering student, and this video is based on my final project, which is about a smart boom gate. So you have noticed that in our country we have load shedding. So this project basically is going to fix that issue of supplying constant power to our smart boom gate.
So the description of the project is that the project is basically about a smart boom gate that will allow easy access in case there's load shedding in the premise or in the apartment. So this project has the following components, which is the LCD that will show if the car is allowed to enter or exit the premise. The LEDs will show if it's safe to pass the boom gate. The relay will switch the light on and off between nighttime and daytime, and this will be detected by an LDR. IR sensor and ultrasonic sensor, they will detect if the car has passed or it's stationary at the gate. The power failure module will allow the battery to supply the Arduino in case there's load shedding, and the ESP will send all the data to ThinkSpeak for cloud connection purposes. This is the project on the breadboard, which consists of a servo and light bulb, an IR sensor, ultrasonic sensor, LCD, Arduino, a relay, and two LEDs, and a power failure module, which is powered by a battery or a power supply. So the block diagram will consist of a Wi-Fi module, IR sensor, ultrasonic sensor. All these components, they will be on my block diagram, meaning that all the blocks that you see the arrows pointing in, meaning that they are my inputs, and all the arrows pointing out, they are my outputs. And all these blocks with the red outlines, they are my designs, meaning that I have implemented them on the project. And then we also have our schematic diagram, which consists of an auto switch, a battery, an LDR, LCD, Arduino, ESP module, IR sensor, ultrasonic sensor, several LEDs, and the relay that is powering my light bulb. And also we have a flow diagram, which will have a start, setup, and a loop. So the first side where you see daytime and nighttime sensor, meaning that it will test everything if it's nighttime or daytime. And also for the setup, it's for the ESP module, which will be sending data to the cloud. And also I have my loop, which is a loop for all my sensors that will be working together. And also I have the entrance, where I'll be testing if the entrance it's allowed or it's denied. Finally, I have my PCB, which consists of all my components that will be mounted on these blocks that you see here.
Okay, so the circuit consists of a fan, a power case that has a battery inside, a power failure module, a circuit on a breadboard, and also my LEDs that will switch on and off during enter and exit, and an LDR, as well as an LCD, and my ultrasonic sensor, and a light bulb, and a servo IR sensor, electric motor, and the final design itself, and lastly my power adapter. Okay, so this is how the circuit will operate. You can see that the car wants to access the system, but the gate is closed, and also you can see that it's daytime. So let's say the car wants to access the system. It will first stand there opposite the ultrasonic sensor, and the gate will be opened. You can also see on my LCD display. So if the car wants to pass now to go to the other side, you can also see that the gate is closed and the red LED is on to show that the gate is closed. So if the car has passed, it will just rest on the side. So focusing on the LDR, which is daytime and nighttime, the reason why that it's still daytime, it's because of the LDR is receiving more light, so you can see on the LCD. So once I close the LDR, it will say nighttime and my light bulb will switch on. The reason why I had to go close by to close it is because of it's receiving more light, and so I have to physically close it. So this is my ESP module that is going to send data to the cloud. So if we come to our serial monitor, we can see that the data is being transferred to the cloud. Okay, so this is my ThinkSpeak page where you can see all my channel stats. There you can see the ultrasonic sensor, you can see the servo, and you can see the LDR. So the reason why you can still see this month is because of I'm having issues with my ESP module. It doesn't want to transmit data to the cloud, but if it had transmitted data, this is the graphs that I was going to get from my ESP module. Okay, so let's say there's an event for load shedding. So basically this circuit is powered with the blue cable. There you can see it's a 5-volt cable, and also it was supposed to be powered by the battery, but the battery is low, so I just replace it with the 12-volt supply. And I will show you now, in case there is load shedding, what will happen to the circuit. So if we unplug this, the circuit should still be operational. It's still operating, and if I unplug this 5-volt, it should go off. So I'll just plug it back in, and I will just switch back my failure module. Okay viewers, these are the challenges that I've been facing on my project. So the first challenge is that I had an issue with the servo. So I've connected the servo on a wrong port, meaning it was not getting enough power, so it was giving my circuit a lot of issues. And then another challenge is that I didn't plug in my voltage regulator properly on the circuit, so some of the components were malfunctioning. So thank you so much for watching my video, and stay tuned for the future videos. Thank you.